Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem. 2976 minimum cost to convert string 1. Okay, so I hope you have already gone through the description, but let me explain you briefly about the problem statement. We have been given a source and we have been also given a target. Idea is to convert source to target using original array and changed array. Okay, so they have mentioned that cost required to convert a to b is basically 2. Okay, so original changed and the cost will be of same length, so cost required to change a particular index character to this particular character. Let's say we are choosing an index I from this original array. The cost required to choose cost required to convert the character at I from original to the character at I in the changed array would be of cost of I. Okay, so I hope this is what it is. Okay, the cost required would be this particular thing. Okay, so let me just jump to IntelliJ. Okay, so if you map these things into a graph, okay, if you see A can be converted into B and B can also be converted into C. Okay, that means there is a connection between these characters. Okay, so I just interpreted these three arrays in terms of graph and its corresponding weights. Okay, let me see how the graph would look like. Okay, so A is connected to B with a weight of 2. If you see, in order to convert A to B, I would be spending a cost of 2. So that is what I have interpreted here. And in order to convert B to C, I need to incur a cost of 5. To convert C to E, I need to incur a cost of 1. From E to B, there is a cost of 2. From C to B, there is a cost of 5. And from D to E, there is a cost of 20. Okay, if you see, this is a weighted directed graph. Okay, now we have to convert, we have to make sure that original and target are both are same. In order to achieve this, we have to convert certain characters. Okay, that means if you see A and A both are same, nothing needs to be done. I have to convert B to C. Okay, so there will be some cost occurred to convert B to C. First of all, whether it is feasible to convert from B to C, that we have to check. If it is feasible, then the cost should be minimum. Okay, we have to return the total minimum cost to convert the string source to string target. Okay, if you see, B can be converted into C with a cost of 5 and C can also convert it into B with a cost of 5. Okay, but this is the possibility. If you see, B can also be converted, C can also be converted into B with a cost of 3. If you choose this particular path, the total cost occurred in this path would be 3. Okay, which is actually lesser than this cost. So our aim is to always choose a minimum, choose a path such that the total cost occurred in the path is minimum. Okay, so if you see, B can be converted into C with a cost of 5, so the cost occurred would be 5. I have to convert C to B. C to B can be converted in this path as well as in this path, but we have to always choose the path with minimum cost. So I will be choosing this path, which will be of 3, and I have to convert D to E, which will incur a cost of 20. So the total cost occurred to convert original to target would be 28. Okay, so as you can see, the idea here is to identify the shortest path from a given source to a given target. If you see here, the source is B and the target is C. Here the source is C and target is B. The shortest path from source to target. Okay, how do you identify the shortest path from source to target in a directed weighted graph? If your answer is Dijkstra, then you are in the right path. Okay, so the idea is to apply Dijkstra algorithm for a given source and identify the shortest path from source to all the nodes and utilize those answers to calculate the total cost. Okay, so if you represent this in terms of adjacency list, this is how we can map it. A is connected to B with a weight of 2, B is connected to C with a weight of 5, C is connected to E with a weight of 1, and it's also connected to B with a weight of 5, and so on and so forth. Okay, so idea is to apply Dextro algorithm on each of these source nodes to identify the minimum cost occurred to reach these destination nodes. Okay, so I hope you are already aware of the Dextro algorithm. If you are already aware of Dextro algorithm, right away you can jump to solve this problem. If not, I will show you how I have implemented the Dextro algorithm to solve this problem. Okay, so firstly what I have done is I have created a map called source to target. So this is not related to Dextro. Why I have created this is because, see, there's a possibility that I have one more character C which needs to be converted into maybe A. Okay, so if I run Dextro algorithm at this particular point to identify the shortest distance from this particular source to all other nodes, I don't have to apply again Dextro algorithm at this given point of time. Okay, that is the reason I have collected for a given character what all destinations I have to reach. Okay, so if there is a one more C, let me just, let's say I have one more character called C, let's assume that, and which has to be converted into D. Okay, so what I have done is I have kept a list, I have kept a map which contains for a given source what all targets I need to convert to. So here for the given input I have to convert B to C as well, also convert C to D as well. Okay, for A there is nothing to do. Okay, for B I have to convert it to C, for D I have to convert into E. So this is what my source to target map is currently contains of. Okay, so if I just run Dextro algorithm for a particular source and identify what is the cost associated to reach all the nodes from a given source, then that should be sufficient. I don't have to apply multiple times the Dextro algorithm. That is the reason I have kept this. Okay, now as I mentioned, I will be having a adjacency list which will contain character and corresponding list of its neighbors with its weight. So that is what it is. I have a character with list of pair, where pair contains V and C, which is V is basically this character and C is basically the cost associated. Okay, so initially I've just populated my source to target. Okay, I'm just iterating from the source. If the source and target, if both are equal, if source and target if both are equal, I don't have to do, I just need to skip it. Okay, if source and target are not equal, that means I have to create this list. Okay, so for that, if it is the first time I have encountered a particular target value, that means I have to create a new list with the specific character itself. If not, that means if I already found it, then I just need to append it. Okay, that is what here I am doing, and then I'm just returning it. This is basic thing. I hope you are able to understand this. And and the next thing is to create the adjacency list from original changed and the cost. Okay, so this part here I'm just creating the adjacency list. Okay, now that the adjacency list has been created, I need to write the Dextro algorithm. So for a given source, for a given start, I need to identify the shortest path from this particular start to all the nodes in the graph. Okay, for a given start, I am identifying the shortest path from this start to all the nodes in this graph. If I given start as C, I will calculate the shortest distance to this, shortest distance to this, shortest distance to this, as well as this. There is no way I can identify the shortest distance from A and B because there is no edge which is contributing to this particular path. So my map will not contain those two graphs. Okay, if the shortest does not contain a particular destination node, that means there is no path which is contributing to the shortest path. Okay, so in Dextro algorithm, as we all know, Dextro algorithm works in a greedy fashion. So I've just have a priority queue with the cost as the factor. So the the node with the pair which has the shortest cost will always be picked first. So in the initial stage, I've just offered into the priority queue the start and the cost associated to reach the start itself. Okay, if you are at C, the cost associated to reach C will be 0. So that is what I have done here. Now as long as my priority queue is not empty, I have to perform certain action, right? So I was just taking the element from the priority queue, and if the shortest distance to this current element, okay, if the shortest distance to the current destination node, if it was already calculated, then I don't have to calculate it. So I'll just simply skip it. If not, that means this is the first time I have retrieved a particular pair from the queue. That means I have identified the shortest distance to this particular destination node. So to this particular destination node, the shortest path would have a cost of this particular value. Okay, now that I have identified the shortest the cost associated to reach this particular node, the shortest path with the minimal cost. Now that for all these corresponding neighbors, okay, for all its corresponding neighbors, I will update the path and then I will offer into the priority queue. Okay, so what I was doing, I was just checking all the neighbors of the current destination node. The current destination node does not, if the neighbors of the current destination node, the shortest path to one of its neighbors, the shortest path to its neighbors, if it is not calculated, then only I will offer into the priority queue. Okay, let's say I have a neighbor to current destination node as B. The shortest path is already calculated. There is no point of calculating again and again the shortest path. Okay, so we have to explore the neighbors whose shortest path is not yet calculated. Okay, so I was just picking those neighbors whose shortest path is not yet calculated, and then I'm just offering into the priority queue with its new cost. Okay, the new cost will be the cost of the current cost to reach the current node plus the edge weight. Okay, so that is what we have done, and in the end I'm just returning the shortest, which will contain the destination and the cost associated, minimum cost associated to reach that particular destination. Okay, now that, so what I am doing is I've just defined a variable called total cost, where I'm just iterating through all the keys of this source to destination, source to target map. Okay, so for each source, okay, there can be, for each source I have to run dextro algorithm on all these characters, because all these characters needs to be converted into these characters. Now I will be running dextro algorithm on all these characters. Okay, now that is what I am doing here. I am just taking the source and then I'm identifying what is the targets. If you see here, I'm just running the cost associated to reach I'm running dextro algorithm on this particular source. Okay, so this is what this line tells. Okay, so this will tell for a given source what is the cost associated to reach all its destination nodes. Okay, now that I have cost associated to reach all its destination nodes, I will just iterate through my targets and see whether this particular target is reachable from my source or not. If it is not reachable, that means I will be returning -1. Okay, if it is reachable, that means there is some minimal cost associated to it, then I will be just including that cost in my total cost. Okay, and then I was just returning my total cost. If any one of the character, if it is not able to convert it to its destination node, that means there is no way I can convert this overall original to its target, then I will, that's the reason I'm straight away returning it -1 over here. Okay, so I hope you understood the overall explanation. Let's try to submit this problem. As you can see, all the base test cases were passed. Let's try to submit it. As you can see, all the test cases were passed and it's also pretty efficient solution. So before jumping dive into the time complexity analysis of this problem, I highly recommend you to subscribe to my coding channel so that you won't be missing the daily content which I will be posting on. Okay, let's try to upskill our problem solving things together on a daily basis. Okay, so let's go ahead and try to analyze the time complexity. Okay, as you can see, for all the possible, for every source I'm running Dijkstra algorithm, right? So if for each and every source I'm just trying to understand the Dijkstra algorithm. So the time complexity will be the time complexity of the Dijkstra algorithm times the number of sources on which we are trying to apply the Dijkstra algorithm. So the time complexity of a Dijkstra algorithm is basically E plus V log of V. Okay, so where E is the total number of edges we have and V is the total number of vertices we have. So that is the overall time complexity. So I hope you understood the time complexity as well. So that's all about this problem. If you like the explanation, and hit the like button, and also share your valuable feedback in the comment section. That will be really helpful, and don't miss to subscribe to my channel if you haven't subscribed yet. That's all about this problem. Thank you.